Hey everybody, this is Mr. Storm. In this video, we are going to get our little ghost guy here moving around on our scene, in our game. If you don't know what I'm referring to, if you don't know why we have this ghost here, it's because you didn't follow along with the lessons last week, nor did you follow along with the lessons this week, which means you're not doing things in the correct order. Go back to the first week, follow those steps to build this project the way it is now. Now, some of you may have already done the steps that you need to in order to complete this project just by following along with the lesson. If you did, great. That's awesome. Then you should be able to just watch this video and just kind of reinforce the lessons that you've learned. But if you didn't, then use this video to kind of like walk you through how to do this stuff. And then I would go back and review those lessons so you can kind of learn the theory behind what we did in this video, right? Anyway, I want all different kinds of learners to be able to access this material. That's why there's a video, plus there's also articles and stuff beforehand so you can see it in different ways. Video game programming can be a bit difficult, right? And so I want to make sure that we're going through this at a speed that makes sense and that you're understanding what we're doing each step of the way. So in this project, we have a ghost object. This is a little ghost that has a sprite attached to it. It has a transform component and a sprite renderer, which means this guy is somewhere in the X and Y of our game, specifically at 0 and 0. And he has a ghost sprite attached to him. Now, in this video, we're going to get this guy moving around on the screen. But in order to do that, we have to add a component that will allow it to be manipulated by physics, or shall we say, that will allow us to manipulate physics to move this object. So in order to add this component, we're going to come over here to the Add Component button, and we're going to look for a component called a rigid body. Now, I've already typed rigid body in here, so what we're looking for is the rigid body 2D object, not the rigid body object. So rigid body is for 3D objects. The rigid body 2D is for 2D objects. So I'm going to click on that, and it's going to open up this new component inside my inspector. Now we can apply physical properties to our object. We can apply things like mass and linear and angular drag, gravity, velocity, inertia, all that kind of stuff. We can apply all of these things to our object. As an example, watch what happens when I play my game. Watch what happens to my object. Oh, and he fell off the bottom of the screen. Now, why did that happen? Well, that happened because we have gravity now being applied to our object. Over here, our gravity scale is 1, and so it's going to have normal gravity being applied to this object, so it's going to pull it down on the vertical axis. So, in order to stop that from happening, we're going to want to change that. Now, notice that I'm still falling on the vertical axis. I'm still falling on the Y because I'm still in play mode. So I'm going to uncheck this, or I'm going to click that play button again to pull myself out of play mode. Now I snap back to the Y, and I'm ready to start moving on. Now, it's really important that you pull yourself out of play mode before you make any changes that you want to be permanent. If I make changes here and then pull myself out of play mode, those changes go away, and I'll lose a bunch of work that I've done. So make sure that you're actually like pulling yourself out of play mode before you move on to the next thing. So let's set our gravity scale to 0 so that gravity is not applied to this object, and let's hit play. Okay, good. He's staying right there in the middle of the screen exactly like I want him to. But he doesn't actually move. I'm hitting the arrow keys and I'm trying to get him to move. He's not moving. Well, it's not that easy. If it was that easy, I don't know. I think everybody would be a video game programmer, right? Well, we actually need to create a script that's going to tell this guy how to apply physical forces to itself. Okay, this script is going to be kind of like an engine that's pushing this thing around, we need that engine. All right. It now exists in the physical world. Well, in the physical world of our game, but we need something to actually push and pull it around and tell it how to behave. So for that, we need to create a script. So down here, I'm going to add another, and one of my friends on Steam is playing a video game. Ignore that. Down here, I'm going to click Add Component. And for this component, I actually want to add a new script. So I'm going to click New Script. And then I'm going to give this new script a name. I'm going to call this Player Controller. Now notice that I didn't put a space in between the words player and controller. That's because script names cannot have spaces. They have to be one word. So I've written player controller. You can name yours whatever you'd like. I always name my player controller scripts player controller. Makes sense to me, right? So I'm going to click create and add. And notice that over here in my assets folder, it's created this new thing that has this hashtag on it. What this means is basically this is a C# script. If I click on it, I can come over here and see what the script looks like. Okay, I don't know what any of that means. That's gibberish. The problem is it's in the wrong place, right? We want to organize our files a little bit. So let's go ahead and create a new folder. And we'll call it scripts. And then we'll place this player controller script inside of this new folder. Okay, so now it's in there, it's organized. If we look at our ghost object again, okay, come on, it's got to update. If we look at our ghost object again, we can see down here we have another component, this player controller script. So it's attached to our object, it's ready to go. Let's go ahead and open up this script by double clicking on it. Now when we do that, it's going to open a special program called Visual Studio. I'm going to mine opened on my other screen. Visual Studio. Now Visual Studio is a it's a programming IDE or integrated development environment, and Visual Studio is by default comes with Unity. So most of you are going to be using Visual Studio. You may have something different. We're mainly going to use Visual Studio here. So that's all my lessons are going to be in Visual Studio. Anyway, let's talk about what this stuff means. So if you've never done any programming before, this may look pretty scary, but hopefully this will be less mysterious by the end of this video. Up here we have these first three lines. They're called libraries. We don't really need to mess with them right now because these are required for all of the other things we're going to do. And so we're just going to leave those alone. On line 5, we have our class. We're going to talk about classes a lot later on in this course. For right now, all you have to know is that this player controller class name has to match your script name or your script won't work. Okay, so make sure that those are the same. Down here, we have two things called methods. We have a start method and an update method. These two are by default always going to start in an empty script in Unity. You're always going to have a start method and an update method. And the difference between these is that the start method is called before the first frame update, meaning at the very beginning of this script, we're going to call the start method, and then it's going to never be called again. We're only going to call this method once, and that's it. So any code that's inside this method is only going to run one time. Down here, we have our update method. This method is called once per frame. Now, most video games run at 30 to 60 frames per second. So this means that either this means that 30 to 60 times per second, we will run whatever code is inside of this thing. So code that we want to constantly be running needs to be inside of this method. Code that we only need to run once will be inside here. Okay. Now, the first thing we have to do is we have to get a reference to the object that we're on, that the script is using, and we have to get a reference to the component we want to change. So over here in Unity, we have our script component that's attached to this object, but we want to actually access this rigid body 2D component because we want to push it around. We want to move, we want to change the velocity of this object. So we need to access this rigid body 2D. We need a reference to that. So let's go ahead and do that. Up here on line 6, I'm going to hit enter to create a new line 7. I'm going to create a variable up here. This variable is going to be accessed by both of these methods. So I'm going to create it up here so that it can be accessed by both. If I created it inside of one method, then the other method wouldn't be able to use it. All right. So I'm going to create a new private variable, meaning it's only used by this script. I'm going to call this, or no, the type of variable is a rigid body 2D, right? Because we're going to get a rigid body 2D and store it in this variable, and I'm going to call it player, okay? So I'm going to create a rigid body or private rigid body 2D called player. And inside the start method, as soon as the script starts, I want to store our player's rigid body into this player variable. So I'm going to say player equals get component, which I can just grab that, get component. And inside of these angle brackets, I'm going to type rigid body 2D. Oh, hello. Rigid body 2D. I want an open and close parentheses and then a semicolon. What this statement means is now we have our player variable, and what's inside the player variable is that rigid body 2D. So anytime we want to access this rigid body 2D attached to this object, all we have to do is type the word player. Okay, perfect. Now we need to get our reference to our input values here in Unity. Unity handles input pretty well. If we go over here to edit and then project settings, we see this new panel that pops up. This panel is our project settings panel. If we click on Input Manager, we should see this here. Now, this Input Manager is what handles all of our input schemes or axes or axes, whatever you want to call it, axes, the multiple, the plural of axis. All right, so one axis, multiple axes. So I'm going to click on this this arrow next to axes, and I'm going to see that I have 30 different, you probably have a different number, but for me I have 30 different axes. Now horizontal and vertical are the first two that we can see here. Let's just focus on horizontal for a second. In our horizontal axis, we can see that his name is horizontal, and then it has a negative button and a positive button. What this will do is if I was to push the left arrow key, the negative button, this will provide a value of -1. If I was to push the right arrow key, then it would produce a value of +1. If I don't push any key, it produces a value of 0. So this horizontal axis can have any number between -1 to +1, depending on how hard I'm pressing the key if it's a sensitive key for input. So we need something that's going to store a number from -1 to +1. So over here in my script, inside my update method, now we're using an update method because I want to constantly be checking for input. So inside my update method, I am going to create a new float variable. A float is a special number that can accept a decimal. It doesn't have to be a whole number. So I'm going to say float h equals, and then I want to I want to access the input manager. So input dot get axis. And the axis I want to get is horizontal. Okay, so I want that horizontal axis. Now, I also want to do the same thing with vertical. Luckily, it's pretty easy to do. Float v equals input dot get, get axis vertical. Okay, so now that I have my horizontal and vertical axes, those are being stored in H and V. Now remember, what this is really going to be is a number between -1 and +1, depending on whether I'm moving to the left or to the right or up or down and how hard I'm pushing that key. So this, whatever stored in H, is technically going to be a number, right? So now I want these key presses to move my object around on the screen. And what I want to actually do is affect its velocity. Notice that we have this grayed out section here called velocity, and we have 0 on the X and 0 on the Y. We actually want to change those values to something. and we want the thing that we change it to be our button input, right? So there's an easy way to do this. All we have to do is say player.velocity. Now we're using player because we want to affect the rigid body 2D component. So player.velocity, and we'll say it equals a new vector2. So a vector in math is an object that essentially has direction and momentum. Basically, it has movement, right? And we want to create a movement on this object in two different directions, right? Or in two different axes, right? We want either up and down or left and right. So we're going to create something called a vector2, a vector that stores two different axes of movement. Now the first axis is going to be the horizontal axis. So we're going to use that h variable that we just created. And the second axis is going to be the vertical axis. So we'll use that v that we just created. Okay. Now this is a pretty rudimentary movement script. If I were to attach this to Unity and start playing it, everything would work properly. Matter of fact, let's go ahead and do that. In Visual Studio, to attach your script back to Unity, all you have to do is click this Attach to Unity button, let it compile, make sure there are no errors down here. I have 0 errors, that's good. I'm going to get rid of this message here. I have no errors. Now I'm going to just hit stop because I don't need to continuously keep compiling my script. And I'm going to minimize. When I come back to Unity, things may be a bit sluggish for a second while that script updates. Let's go ahead and take a look. And notice that now all those changes I've made have updated in here, okay? All right, so now I should be able to hit the play button and move my ghost around on my screen. And I can. Look at it. He's moving. But he's moving kind of slowly, right? So we need to fix that. Let's think about why this is happening. All right, let's go back to our script. Now, remember I told you that this input will give us a number between -1 and +1, right? Well, -1, +1, those aren't really extreme values. It's not a lot, right? So we can't really be moving super fast if our speed limit essentially is 1 or -1. So how do we improve that? Well, what we can do is we can create another variable that will allow us to multiply that 1 by a certain value so we can go faster. You know what? It would also be nice if we could create a variable that we can change here in the Unity editor so that we can actually change the variable here instead of having to come back to our Visual Studio script every single time we want to change it. So let's do that actually. Up here next to or underneath our private variable, let's create a public variable. Now a public variable will mean that it can be edited inside of Unity. And we don't have to come back to our script. So it's a pretty good, handy tool for us to use. And we're going to create a public float. And let's call it speed. Now let's set it equal to, I don't know, 5f. Now the f is just because this is a float number. So we just want to indicate that it's a float. Okay, so now we have a speed limit, and the speed limit is 5 times faster than it is here, but we have to actually apply that speed limit to our movement. So all we have to do is after this parentheses, we just times this entire movement by our speed variable. Okay, perfect. Let's attach that to Unity. And let's come back here and see if that worked. All right, let's click on our ghost. The first thing we should see is down here, we now have an option called speed that we can change. We can just change it here in Unity without having to go back to our script. So if 5 isn't too fast, or if 5 is too slow or too fast or whatever, we can change it here. Let's test it out and see how it works. Hey, much better. It feels much zippier, right? Maybe a bit too fast, but honestly, I like it a lot. It feels nice. Now I'm just pushing the arrow keys. I can use WASD, or I can use like a Super Nintendo controller. If you have a video game controller that has a USB interface, you can plug it in to a USB port, and then you can use that to move around. Really anything that is tied to the horizontal and vertical axes will allow you to move. A joystick, what have you, right? So there it is. There you have it. We went from a completely static object that had no movement to creating something that we can actually manipulate and change and play with, right? Just with a couple of lines of code. We're in under 25 lines of code for this entire program, and we've written less than half of them. So we've only written 1, 2, 3, 4, 5, 6. We've written 6 lines of code, and now we have a movement function in our games. That's pretty cool. All right. Hopefully I didn't go too quickly. I wanted to keep this as short as possible, but I also wanted to explain some of the concepts. If you want a deeper explanation of some of the stuff that we've just went over, review the previous lessons from this last week. Once you get your game working like this, I want you to record a video of your game actually working and then upload that video to Canvas. If you don't know how to record a video, then again, go back and review the lesson on recording videos, and it'll show you exactly how to do that. Okay, this was fantastic. This was fun. Thank you guys for watching, and I'll see you later.